Okay, so what we're doing is we're talking a little bit about parallel lines, skew lines, parallel planes, and then most importantly, angle pairs. This is the work through of some of the problems on the assignment for Chapter 3, Section 1. The assignment is page 144, 11 to 42, I believe. Okay, so let's start off just with number 11, the first one. So 11 through 16, we're looking at that figure over to the right. And so number 11 says a pair of parallel planes. Now keep in mind the plane is a two-dimensional object. It's like the cover of a book. So if you're thinking about a book or a box, parallel planes would be like the top and bottom, or the left side, the right side, the front side, the back side. So what we can do here is we can look at, I hit the wrong button. Okay, so let's go there. We can look at that top plane and the bottom plane. Okay, and those are parallel. If they go on forever, they're never going to meet. So we only need 3 points to define the plane. So we're going to call that JGD and HBA. Again, those are 3 points, so that forms a plane. Now we can also sit there and look at the two sides. That'd be JCL and DHB. That'd be fine too. So now what we're going to do is we're going to look at number 13. So it's all lines that are parallel to DH. So there's line DH right there. Now the parallel lines are going to be in a plane. Now keep in mind here, each set of parallel lines needs to be in a singular plane. That does not mean that all parallel lines have to be in the same plane. I'll explain that a little bit more after I kind of give you the answer. So the answers here would be any of the corners. GB, FA, JE, or CL. They're all parallel. See, I put the little parallel sign on them. Now you know they're parallel. So here's the thing. If I have DH and CL, okay? I know that those two are in a plane. That's that plane CDH, okay? And if I have, let's say, plane JE and DH, those two are also in a plane. We call that plane JDH. Now here's the thing. That is a different plane than CL was in. And that's fine. In determining lines that are parallel to DH, they don't necessarily have to be all parallel at the same time. Because CL can't be, remember, parallel lines have to be coplanar. CL can't be coplanar with DH at the same time that JE is coplanar with DH. We're talking about two separate planes there that would intersect then in DH. But I hope that made sense and didn't confuse you further, but it would be all of the corners. Okay. So moving on, when we're looking at 17 through 20, keep in mind we are looking for 2 lines in the transversal. Now there are a total of 5 lines in there, okay? Which means that there are a total of 20 pairs of 2 lines, and then you add to that times the different transversals, and you've got about 60 different pairings. Okay. My math might be a little off on that. Anyway. So we're looking for corresponding angles. So we're going to start off with the 2 black lines in the right transversal. Now, as I go through this, all my black lines, all the lines are going to be black for the 2 lines that get crossed by the transversal, and the transversal is going to be red. The coffee, and we're back at it. So, the corresponding angles. Now remember, corresponding angles, what that means is they're on the same side of the transversal and in the same position. So we have top left, top right, bottom left, bottom right, bottom right. And so we look to see if we have any angles that are in both positions. Well, we have 8 labeled 8. That made no sense. Anyway, we have angle A. That's in the top left position. So we look over at the other top left position right there, and there's no named angle. Okay? So then we look again and we see, well, over on the left-hand side, we have the bottom right there, 7. And we look over at the bottom right there, and we see 6. So we go, hey, 7 and 6. Those are going to be corresponding angles. So the next one's actually kind of tough. A lot of people have trouble with it, so I'm just going to give it to you. The two lines, so if we looked, a lot of people say like 3 and 4 are 1 or 2. The problem with 3 and 4 is that they don't have, if you look back at a transversal, it intersects two lines at distinct points, meaning it does not intersect both lines at the same place. Here, if we were to say that line C is our transversal, that's this one right here, and that lines D and B were our lines, notice that they intersect all at the same place. Okay, if we wanted a real transversal, it would have to be something along these lines that hit them both in separate places. Since we don't have that, 3 and 4 cannot be considered corresponding angles because they're not on the same side of a transversal. Why? Because under the definition of a transversal, C isn't. Okay. Not distinct. Okay. Now 2. 2 does have a corresponding angle. When we look at, and that's 5. So when we look at 2 and 5, we see that in fact there are 2 lines right there crossed by a single transversal. And we notice that 2 is in the top right position and that 5 is in the top right position. 2 lines crossed by a transversal. They're both on the same side of the transversal and in the same position, top right. Hold on, I need to go yell at my dog to stop drinking the cat's water. That's done. Okay. So, moving on. So those are the 2 corresponding angles. You should also name the 2 lines with it. So it'd be line, that's line A. Line A and B. Transversal is D. And then you do the same thing for 2 and 5, except it would be lines B and C, transversal E. Okay. Same side interior angles. Now, same side interior angles, we're going to look here and we're going to say that that's the interior and 6 and 5 are on the same side. So 6 and 5 work. Now, some of you guys might want to go, well, if 6 and 5 works, why don't 1 and 7 work? And here's why. If I said that these were my 2 lines, lines D and E, and that well, then what's my transversal? Well, my transversal can't be this one, because that doesn't affect 7 at all. And if I do this as my transversal, here's the thing, that 7 would be an a same side interior angle with this angle right there, 1 and 2. But 1 isn't created by E and A, it's created by A and C. So because they're not on the interior of the same line, they're not technically same side interior angles. Okay, moving on. So I've been thinking about it, And I'm wrong. 7 and 1 are, in fact, same side interior angles, and here's why. So if those are my two lines, if D and C are my two lines, and A is my transversal, okay, so A is cutting across both of these, okay, then the interior would be here, because that's in between the two lines. Exterior would be out here. 7 and 1 are on the same side of the transversal. On the interior, same side interior angles. I don't know what's going on here. Oh, yeah, I do. Okay. Here, let's go back to what I just did. And we're going to erase all this. So now we're at alternate exterior angles. And for that, A and D are going to be our lines. So that's the interior right there. Okay. So if we look at 1, so 1 and 3 there are also same side interior angles, which also means that 2 and 4 are same side interior angles. Okay, so we got a bunch of same side interior angles. Got all of them. Okay, so lots and lots of same side interior angles. Just so you guys know, there are 2 sets of alternate interior angles and only 1 set of alternate exterior angles. Okay. So let's look at 23 now. 23 is harder than 21 and 22, so I figured I'd do that for you. And really, the difficulty in 23 comes from the fact that we have 3 lines instead of 2. Keep in mind, when we're looking at angle pairs, we're only going to be looking at 2 lines at a time and the transversal. So, let's look at angle 1 and angle 2. So, those are my 2 lines. That's my transversal. I'm switching colors for this one. And I'm looking at 1 and 2. Now, they have to be one of 4 pairs. Alternate interior, alternate exterior, same side interior, or corresponding. So first things first, they are both on the same side of the transversal. Okay? So being that they're on the same side of the transversal, we can get rid of alternate interior and alternate exterior. We then have to figure out whether they're same side interior or corresponding. Well, if they were same side interior, they'd be both on the inside of the angle. So instead of one being up here on the outside, one would be right there on the inside. It's not so. They're on the outside, so they are corresponding. Now here's the other thing we could do. We could look at them and we could go, okay, well that's number 1's top right. Number 2 is also top right. Therefore, they're corresponding. So now let's look at 5 and 6. Again, we're going to look at those 4 possibilities. And the first one we look at is alternate interior. Well, we know that these are on opposite sides of the transversal. So we're looking at our 2 alternates. So it's either alternate interior or alternate exterior. Being that they are both on the inside, on the sandwich part of the diagram, blue interior, green exterior, they're alternate interior angles. Finally, we're looking at 3 and 4. They're both on the interior, both on the same side. So we're just going to call it same side interior. Okay, I need to switch over to a different one as we go on to the next page. Give me just a second. Hey, there we go. Okay. So 25, 26, 27, 28, check your bell work, okay? What they're asking is how many pairs of each type, how many pairs of alternate interior angles, corresponding angles, vertical angles, and alternate exterior angles occur when we do that. The bell work from today, the 18th, accounted for 25, 26, 27, and you guys should be able to figure out 28. Okay, so moving on. I'm going to leave 29 and 36 for you guys. They are word problems. They require a little bit of thinking, but I really want to see what you guys can do with them by just actually sitting there and focusing on them and trying to get a meaningful answer. Okay. So, let's look at number 30. So we're describing these statements as true or false. We assume that lines and planes that appear to be parallel are in fact parallel. So we're looking at CB and HG. And we're told that they're parallel. They're on opposite sides of what looks like a rectangle. So I think that's safe to assume that that's true. Let's look at 31. ED and HG. So we have the front corner of the house, the front corner bottom of the house, and one of the back corners of a roof. These are not going to be parallel. Though they, in fact, will never meet, it's not because they are parallel. Remember, parallel lines have to be coplanar. If they are not coplanar and don't meet, they are called skew. Okay? So then you have 32, 33, 34, 35. You guys should be able to do those. Okay, so I'm going to go through all of 37 through 42. Two lines are coplanar. Two parallel lines are coplanar. So what we want to do is we want to look at the definition of coplanar and two parallel lines. And the definition of parallel lines mandates that they are coplanar. So two parallel lines are always coplanar. Two skew lines are coplanar. Well, if we look at the definition of skew lines, it says two non-coplanar lines. So two skew lines are coplanar? Nope, never. Okay? Because if they're skew, they are, by definition, not coplanar. Two lines that do not intersect are parallel. Well, it depends. Are they coplanar or not coplanar? If they're coplanar, they're parallel. Or two planes that do not intersect. Sorry, I read that wrong. Two planes that do not intersect are parallel. And that is true. If we look at the definition of parallel planes, we get two planes that do not intersect. We cannot have skew planes. The fact that planes are in two dimensions means that they can't be skewed to each other. Two lines that lie in parallel planes are parallel. Well, that's going to be a sometimes, and let me explain that. If I have two planes here that are parallel, pretend that each of those green boxes is a plane and that they are parallel planes. If I have two lines going opposite like that, those are going to be skew. However, if they're going the same way, then it would be possible to create a plane right there in which they both exist, and therefore they'd be parallel. So that would be sometimes. Finally, two lines in intersecting planes are skew. That is going to be sometimes. Because the planes are intersecting doesn't mean that the lines must, okay? Now, two lines in intersecting planes could also intersect, or they could be parallel. Okay? So it really depends on kind of where they are and how they work and all these other things. So that's a sometimes. And a line and a plane that do not intersect are skew. Again, we want to go back and look at the definition of skew. And skew is two non-coplanar lines. It says nothing about planes. And in fact, a line and a plane that do not intersect are considered parallel. Okay. Now I know that we've talked about parallel lines and parallel planes, and not just the word parallel, but a line can be parallel to a plane. It cannot, however, be skew to a plane. A line is either parallel to a plane or they intersect. That's it. And that is it. So hopefully that'll help you out. I really want you guys to focus on those two word problems, and be ready for tomorrow when we start talking about proving these true. Hope everyone has a good night and is ready for school tomorrow morning.